Hello friends, very good morning to all the students. Are you getting my voice clearly? Am I audible to you? Okay, fine. Getting the positive responses. Very good. Thank you all. So friends, today we are starting with the first chapter of the subject of basic mechanical engineering. Dear friends, remember this is the simplest chapter of the subject of BM. Majority of the points of this chapter you have already studied, but we will be giving some engineering or technical perspective to the different topics of this chapter. So friends, whenever you are preparing for the examination, theoretical examination, I suggest that never skip this chapter. Prepare this chapter perfectly and attempt all the questions which are asked from this chapter. Because considering the theoretical examination, this chapter is a very scoring chapter. You can get the full marks if you are attempting the questions from this chapter and writing the answers perfectly. And in this chapter, there are no numericals, there are only theoretical concepts, and also there are no practicals. So basically, this is a very fundamental or the simple chapter related to the mechanical engineering. So I hope that majority of the students have joined the group. So let us start with the first chapter, that is the introduction. So friends, these are the contents or the topics which I am going to discuss in the current lecture. If you are observing the names, you will be getting the idea, sir, maximum points, we are aware of it, we have already studied at our school level, but we will discuss some of the technical perspective of those points, and also we will interact at some of the points. Dear friends, remember one point, at the end of my lecture, I will give you the session for your doubt solving. So at that point of time, you can ask me the doubts or the questions or the points which you have not understood in this lecture. Okay, so let us start with the first topic of the current lecture. First topic, that is the prime movers. Dear friends, this is one of the most important question of the theoretical examination. I repeat the point once again, dear friends, this is one of the most important question of the theoretical examination. The question is asked such as, what is the prime mover, and give the classification of the prime mover. The answer is very simple, so try to understand the points, and if you want, you can note down the important points which I am discussing in the lecture. So as you are seeing that in the block diagram or the pictorial representation, we are seeing that the prime mover is taking the energy from the natural sources. Now if we consider the natural sources, they are the sources which we get from the nature. So for example, we can consider it can be the coal, petroleum, natural gas, etc. They all are the natural sources. So prime mover, it takes all these natural sources, and after taking these natural sources, the prime mover converts the energy of the natural sources and the energy of the natural sources is converted to another energy that is known as the mechanical energy. So if we consider the prime mover, it is simple a driving equipment or can be considered as an energy conversion system. The output of the prime mover or the result obtained from the prime mover can be in terms of mechanical energy or the useful work or the shaft power. Dear friends, the shaft is one of the components which is used for the power transmission. So if we have understood the concepts of the pictorial representation related to the prime mover, then I expect that definition will be much clear to you. The prime mover is a device which uses the natural sources to convert their energy into the mechanical energy or the useful work or the shaft power. Repeating the definition once again, so try to remember, try to understand the basic concept, the theoretical approach. Definition of the prime mover. Prime mover is a device which uses the natural sources to convert their energy into the mechanical energy or the useful work or the shaft power. The prime movers are considered as the primary sources of the mechanical energy or the power. So whenever we are considering the production of the mechanical energy or the mechanical power, the first application that comes in our mind, that is of the prime movers. The energy generated by the prime mover is transmitted to the another mechanism or the machine, and the mechanism or the linkage that transmits the mechanical power developed by the prime mover is called the drive. So these are some of the basic points related to the prime mover. So friends, in this theory, you need to understand this pictorial representation as well as the definition. So final point, repeating the definition once again, because I have already informed you that it is one of the most important questions that is asked in the theoretical examination. So repeating the definition, prime mover is a device which uses the natural sources to convert their energy into the mechanical energy or the useful work or the shaft. Proceeding further with the discussion of the prime mover, the next topic, that is the classification of the prime movers. So friends, if we understand the definition of the prime mover, one point we can conclude that the output of the prime mover, that is fixed, and in the output we are getting either the mechanical energy or the useful work or the shaft power. But we can change the input to the prime mover. So the classification of the prime mover is done on the basis of the types of the energy sources used by the prime mover. That means what are the input parameters to the prime movers. On the basis of this point, the prime movers are classified into two types: the thermal prime movers and the non-thermal prime movers. The thermal prime movers, they are related with the heat energy, and the non-thermal prime movers, they are not related with the heat energy. Proceeding further with the classification, the thermal prime movers are further classified into 5 different points. The first classification, that is the fuels. And in the fuels, the examples of the prime movers are the heat engines. In the heat engines, we are undergoing the combustion of the fuel. That means we are burning the fuels for producing the mechanical power. So on the basis of the combustion, the heat engines are further classified into two types: the external combustion engines and the internal combustion engines. From the name only we can understand that in the external combustion engines, the combustion of the fuel will be taking place outside the engine cylinder. Whereas in the internal combustion engines, the combustion of the fuel takes place inside the engine cylinders. So the automobiles which we are using in our day-to-day life, all are using the internal combustion engines. Next classification in the thermal category, that is the nuclear energy, and the examples are the nuclear power plants which are generating the electricity. Next is the geothermal energy, and the examples are the geothermal power plants. The geo, it is the term related to the earth. So the thermal energy which is obtained from the earth's surface, that can be used in some of the power plants for converting into the mechanical energy. I think you are aware about the biogas industry or the biogas energy. So the biogas energy is utilized in the power plants, that is the biogas plants or the natural gas plants, and in simple sense we are knowing it as the gobar gas plants. And the last classification in the thermal prime movers, that is the direct solar energy. And you are aware that right now majority of the systems related to the mechanical energy, they are being converted to be using the solar energy. So friends, I hope you are getting the points which I am explaining in the session of the prime mover. Please give me your reply in the chat box that you are understanding the points which I am explaining. The classification of the prime movers, they are the two types, the thermal and the non-thermal. Very good. I am getting some of the good responses from the good students. Very good. Thank you all. So I think the discussion related to the thermal category is clear to the majority of the students. So let us proceed to the next classification, that is the non-thermal classification. In the non-thermal classification, I already told you that it is not related with the heat energy. So in this non-thermal category, we are having three types: the hydel energy or the water energy, that is the hydro power plants or the water power plants. If you are aware that at the Gujarat Statue of Unity Sardar Sarovar project, that is the hydro power plant. The next type of the non-thermal, that is the tidal energy, and we are using the motion of the tides for generating the power in the oceans. And the final name, I think you are well aware about it, that is the wind energy. And the examples of the wind energy are the windmills. Okay, you are well aware about the windmills, and windmills, they are mainly installed at the seashore level so that we are getting good amount of the wind speed, and then we are generating a large amount of the electricity. Let me ask you one of the general knowledge question at this point. Anybody can give me the answer? Who is the largest producer of the windmills? Which company is the largest producer of the windmills at our Gujarat level? Okay, one of the student has replied Tata. No, it is not the answer. Adani, okay, Adani is also not the correct answer. Anybody is having this knowledge, which is the largest producer of the windmills? Okay, Siemens is not the company at India level. I am asking about the India current session. Tesla, okay, dear friends, Tesla is mainly focusing on the automobiles. Also, they have now diverted. Okay, one of the perfect answer. Jay has given me the answer. Very good, Jay. Rule number 75, he has given the answer, that is the Suzlon. One of the perfect answer which I was expecting from the students. So dear friends, remember Suzlon, that is the India-based manufacturer of the windmills, and it is the largest in the area of generating the windmills. Basically, the Suzlon is developing the wind turbines. It is not generating the complete windmills, but the blades and the turbines which are used, that is the work of the Suzlon. So I hope now the picture is perfectly clear in your minds and you have perfectly understood the question, what is a prime mover and what is the classification of the prime movers. Let us proceed further with the next topic. What is mass and what is weight? I hope you have heard these terms previously. So can you share your views on the concept of the mass and the weight? Any student can reply in the chat box. What are your comments on mass and weight? Okay, weight is mass multiplied by the gravitational acceleration. Okay, Dev Shah has replied me. Mass is equal to, okay, mass is the amount of matter. Okay, Dev Shah has again given me the answer. Very good. Weight differs from places to places. Okay, mass is fundamental property of all the matters. Okay, very good. So seeing your answers, I am getting some positive vibes from your side that you are aware about the concepts. So let us refresh those points by making the comparison between the mass and the weight, so that the concept is perfectly set in your minds and it is easily remembered. So first, making the comparison, taking the definition. So mass is the amount of matter which is contained in the body, whereas weight is the amount of force acting on the mass due to the acceleration due to gravity. So when we consider the notation, mass is always represented by small m, whereas weight is denoted by capital W. The type of quantity, mass is a scalar quantity, whereas weight is a vector quantity. If we consider the formula, mass is equal to volume into density, product of volume and density, whereas weight is equal to mass into acceleration due to gravity. Dev has given me this answer related to the weight. That was one of the correct answer. The SI unit, the standard unit for the mass, we are considering the kg, and weight, since it is a type of force, we are considering it to be Newton. And the final point of comparison, that is the feature, the mass that does not depend on the gravity, hence it is constant everywhere, whereas the weight, it depends on the gravity and so it varies from place to place. So friends, this is the basic understanding related to the concepts of the mass and the weight. Let us proceed further with the next topic, that is the force. Before explaining the concepts of the force or the technical perspective, can anybody tell me which law of Newton gives the definition of the force? Which law of Newton gives the definition of the force? Okay, some of the students has given me the answer, second law, some are telling the third law. Okay, some students are giving me the answer, first law. Okay, third law, first law. Okay, so here I am getting some mixed responses from all the students. Okay, fine, no issue. So basically friends, the Newton's second law of motion that gives the definition of the force. Try to remember this point. In simple, force can be considered as a push or pull of an object. It is an external agent which is capable to change the state of rest or the motion of the body. That means if the body is at rest, we can apply the force and the body undergoes the motion. If the body is in motion, if we apply the force, there are chances of the acceleration or the deceleration. The force, as we are aware, it is a vector quantity, so it is having the magnitude as well as the direction. So according to the Newton's second law, I think you are aware about this point. The quantity of force is expressed by the vector product of mass m and the acceleration. So the formula for calculating the force, that is F is equal to ma, where m is the mass of the body and a is the acceleration of the body. If we consider the CGS units of the systems, that is the centimeter, gram, second system, the force is expressed in dyne. Whereas if we consider the standard international system, that is the SI unit, the force is expressed in Newton. If we want to consider the larger units of force, we can tell it as kilonewton as well as the meganewton. So friends, let me ask you one of the question. 1 meganewton is equal to how much Newton? 1 meganewton is equal to dash Newton. Any student can give me the answer? Okay, very good. 10 raised to power 6. Very good. That is the perfect answer. That is the perfect answer. Very good. Thank you, students. Thank you for the positive answers from your side. So proceeding further with the effects of the force, some of the pictorial representations I am showing you so that the idea becomes more clear to you. A man is using the force to move a stationary lawn mower for the gardening purposes. A footballer uses a force to change the direction of the motion of the ball. The next effect, that is the cyclist uses a bigger force to pedal his bicycle and increase the speed. The baker uses a force on his dough to give a particular shape to the puff. So friends, we are using the force in tremendous cases in our day-to-day life. I think you can also give some of the more examples where we are using the force. The concepts are very simple. Proceeding further with the next topic and the important topic, that is pressure. Because friends, in the basic mechanical engineering, several times we will be using the concepts of the pressure. So try to focus on this topic and understand the concept perfectly. So pressure in simple sense is defined as the force applied perpendicular to the surface of an object per unit area over which that force is distributed. So basically, if we consider this technical definition of the pressure, according to this definition, in simple sense, we can write down pressure is equal to force upon area. Considering the notations, capital P is equal to F divided by A. Here in the picture, I have given two examples. In the first example, we are seeing that because having the larger area of the wooden block, we can able to generate low amount of pressure by the black box which is installed upon the wooden box. But in the second case, we are seeing that the area of the wooden box is reduced. So we are getting the higher amount of pressure with the same amount of the force on the black box. So considering this example, we can conclude that The pressure between the two solid surfaces depends on two important things: the force between the surfaces and the area of contact between the two surfaces. So the final and one of the important point to remember this point: the greater the force or smaller the area, the greater is the pressure. This is the fundamental or the basic most important point to be understood in the mechanical systems whenever we are dealing with the approach of the pressure. Proceeding further, that are the units of the pressure. So PSI, that is the pounds per square inch. Bar, that is one of the unit of pressure. 1 bar equals the atmospheric pressure on the earth at the sea level. Pascal, that is one of the important units. So 1 Pascal equals 1 Newton per meter square. So 1 Pascal is equal to 1 Newton per meter square. Inches of mercury, you are aware about it. Torr is also a unit of pressure, and inches of water. Friends, I have intentionally highlighted this point and also written, that is remember. So I suggest that you also note down this point. 1 bar is equal to 10 raised to 5 Pascal or Newton per meter square. Because whenever we are solving the numericals in this subject, we need to use this conversion. Because in the numericals, majority of the numericals will be given the pressure in terms of bar. So we need to convert the bar into Pascal. So I hope you have mentioned or you have understood, or if necessary you have written this point of the remember in your notes. Proceeding further, the types of pressure, there are 5 types of pressure. The first one is the gauge pressure. The gauge pressure is a type of pressure which is measured by the pressure gauge. Dear friends, pressure gauge is a device which is used for measuring the pressure. So that type of the pressure is known as the gauge pressure. Atmospheric pressure, it is the pressure exerted by the atmospheric air. From the name only we can understand. Standard atmospheric pressure, that is the atmospheric pressure which is coming at the mean sea level. And if you remember, we are calculating the standard atmospheric pressure by considering 760 mm of mercury column. I hope you have already studied this point at your school level. 760 mm of mercury. The fourth type of pressure, that is the absolute pressure. Absolute pressure is the summation of gauge pressure and the atmospheric pressure. And the final pressure, that is vacuum. Vacuum is the pressure which is considered below the atmospheric pressure. And if we consider the vacuum as the pressure, we are using torr as the unit of the pressure. So friends, proceeding further with the next topic, that is the work. Work refers to an activity involving a force and the movement in the direction of force. The work is done on an object when the force acts on it in the direction or as the component in the direction of motion. In simple terms, considering the definition, work is equal to force into the distance moved in the direction of force. Work is measured in joules, that is J. So J is equal to Newton into meter, where Newton is a quantity for the force, meter, that is the unit for the distance. Moving further, that is power. So power is the rate at which the work is done. So mathematically, the power is computed using the equation, that is power is equal to work upon time. Work, we have already studied force into displacement, so that is Newton meter per second. And if we consider this concept of Newton meter per second, then the standard unit of power, that is watt. Considering the automobile engines, we are considering horsepower as the unit of power. So 1 horsepower, that is equivalent to approximately 750 watts. So these are some of the fundamental or the basic concepts related to the work and the power. Moving further, that is energy. Energy is the capacity for doing the work. Energy is necessary to accomplish the work because friends, whenever we want to do the work, always we require the energy. So this is a very important statement. The energy is just like the currency for performing the work. In the pictorial representation, the different forms of the energies are shown. The mechanical energy, the nuclear energy, the chemical energy, electrical, thermal, electromagnetic likewise. And also you can add some more examples of the energy or the types of energy. The important point which you need to remember, that is this point, the types of energy are further divided into two types. They are the high grade energy and the low grade energy. Dear friends, understand this concept perfectly. High grade energy is that type of energy that can be completely converted into work. And if we consider the technical perspective, we cannot have the complete conversion of energy into work. Always there will be some percentage of the losses. But in the high grade energy, though the losses are taking place, we are neglecting the losses. And since we are neglecting the losses, we are telling that the energy is completely converted into work. Some of the examples of the high grade energy are the mechanical energy, the electrical energy, the wind energy, etc. An opposite of the high grade energy, that is the low grade energy. Only a certain portion of the energy that can be completely converted into work. That means in the low grade energy, we will be totally considering the losses which are taking place in the conversion. Some of the examples of the low grade energy are the thermal energy or the heat energy of the nuclear fission. So I hope you have understood the concept related to the high grade energy and the low grade energy. Very important, can be asked in the theoretical examination. Moving further, we will understand only one type of energy, that is the mechanical energy. There are basically two types of the mechanical energy. They are the kinetic energy and the potential energy. The kinetic energy is the energy which is possessed by the body by virtue of its motion. So whenever a body is in motion or whenever the body is moving, we are telling that the body is possessing the kinetic energy. I hope you are well aware about the equation for finding the kinetic energy. That is, kinetic energy is equal to 1 by 2 mv square, where m is the mass of the body in kg, v is the velocity of the body in meter per second. Now friends, one of the question from my side, can you give me some of the examples of the kinetic energy which you are aware of? Can you give me some of the examples of the kinetic energy which you are knowing? Okay, one of the student has given me the answer, that is moving car. Okay, can be considered. Flowing water, okay, water which is in motion, river flowing, moving ball, very good. Ball traveling after being kicked, okay, that can be considered. Okay, so you are aware about the kinetic energy. Very good. I am getting some of the good answers from the students. That means you are understanding the concepts. Okay. Moving further, the next energy, that is the potential energy. The energy possessed by a body by virtue of its position or the elevation. So in the potential energy, we are considering there is no motion of the body is at rest. So considering the position or the elevation of the body, we are considering the potential energy. The following is the expression to determine the potential energy, that is PE is equal to mg into h. where m is equal to mass of the body in kg, g is the acceleration due to gravity which you are aware about, that is meter per second square. The value is 9.81 meter per second square. H is the height of the body because we are considering the elevation and height is considered in meter. Again, similar to the kinetic energy, can you give me some of the examples of the potential energy? Any student can give me the example of the potential energy? Very good. Kashyap has given me the answer. Twist stability, a raised weight, stationary object, ball thrown up, okay, ball kept on ground. Dev Shah, very good answer. Water stored behind the dam, very good. Jay has given me the answer. Okay, elastic potential energy, Hetu Desai, that is not the example. Child at the top of the slide, very good. A rock sitting on the edge of the cliff, okay, can be considered. Okay, so because of the position or the elevation, you are giving me the examples. Very good, perfect examples. Proceeding further with the next topic and the last topic of the current session, then I will be shifting over to your doubt solving sessions if you are having any question. So law of conservation of energy, I hope you have also studied this concept. Energy that can neither be created nor be destroyed. It is possible to convert one form of energy into another form of energy. And the third statement, the total amount of energy remains constant before and after the transformation. This transformation, it represents the conversion of energy into the work. Okay, so these are the three important statements in context of the law of the conservation of energy. Since it is important, I am repeating once again, though you are already aware of it. There are three statements. Energy can neither be created nor be destroyed. It is possible to convert one form of energy into another form of energy. The total amount of energy remains constant before and after the transformation. So with this, I am concluding the session from my side. Now friends, the session is open to you. We are having some few minutes for the doubt solving. So any student is having any question, you can ask me in the chat box. Sir, what is the tidal energy? Okay, tidal energy is the energy which is generated by the movement of the tides and the apes, which is developed at the oceans. At the oceans, because of the movements of the moon and the sun, the tides and the apes are generated. So in the oceans, we are installing the turbines. So by the movement of the tides and the apes, we are rotating the turbines and generating the electricity. Sir, can you repeat the gauge pressure and the standard atmospheric pressure? Okay, the gauge pressure is the pressure which is measured by the pressure gauge.